what is the value of 60 is root 3, and the hypotenuse is still 2. So sine 60 is root 3 over 2. Now what about cosine 60? So adjacent to the 60 is the 1, and the hypotenuse is 2, so cosine 60 is 1/2. Notice that cosine 60 is equal to sine 30, and sine 60 is cosine 30. Why is that? Cosine is the cofunction of sine. Cotangent is the cofunction of tangent. Cosecant is the cofunction of secant. The cofunction is equal to the function 90 minus x. So cosine x is sine 90 minus x. Whenever the cosine angle and the sine angle add up to 90, cosine equals sine. For example, cosine 30 is equal to sine 60. Cosine 20 is equal to sine 70, because 20 plus 70 adds up to 90. Cosine 0 is equal to sine 90. Sine 90 is 1, cosine 0 is 1. So cosine 15 degrees is equal to sine of what angle? So all you have to do to find the missing angle is 90 minus 15, so therefore this is 75. But now let's get back to the 30, 60, 90 triangle, because you can use that to find the values of larger angles. Now you need to understand the concept of a reference angle. The reference angle is always between 0 and 90. It's an acute angle. An obtuse angle is an angle larger than 90. A right angle is equal to 90. In quadrant 1, this angle represents the reference angle. In quadrant 2, the regular angle is over here, but the reference angle is between the x-axis and the blue line, so this is the reference angle. In quadrant 3, the reference angle is over here. The reference angle is always between the x-axis and the hypotenuse of the triangle that is formed. So if you have an angle in quadrant 1, the reference angle is equal to that angle. If you have an angle in quadrant 2, the reference angle is 180 minus the angle in quadrant 2. Now, if you have an angle in quadrant 3, the reference angle is the quadrant 3 angle minus 180. If you have an angle in quadrant 4, the reference angle is 360 minus the angle in quadrant 4. So let's go over some examples. So let's say if you have an angle of 60 degrees. What is the reference angle? So because the angle is between 0 and 90, the reference angle is equal to that angle. It's going to be 60 degrees. So if the angle is in quadrant 1, it's the same as the reference angle. Now let's say if the angle was 140 degrees. What's the reference angle? So 140 is in quadrant 2. So the reference angle is going to be 180 minus the angle in quadrant 2. So 180 minus 140, it's 40 degrees. To see it visually, here's 0, this is 90, 180, and 270. So 140 is somewhere in this area. So from the x-axis to this angle, that's positive 140 degrees if you travel counterclockwise. This angle on the inside between the x-axis and the hypotenuse of the triangle formed, that is the reference angle. So it's the difference between 180 and 40. So that's why this is equal to 40. It's the difference of these two angles. Now let's say if we have another angle. Let's say the angle is 225 degrees. So that's in quadrant 3. What's the reference angle? The reference angle in quadrant 3 is going to be the angle in quadrant 3 minus 180. So that's 225 minus 180, which is 45 degrees. So 225 is right here, and the reference angle is always between the x-axis and this vector. So here it is. As you can see, it's the difference between these two numbers. So it's 45. The reference angle is always between 0 and 90. Let's try another example. Let's say the angle is 330 degrees. What's the reference angle? So the reference angle in quadrant 4 is 360 minus the angle in quadrant 4. So that's 360 minus 330. So it should be 30 degrees. So 330 is somewhere in this area. So starting from the x-axis, traveling all the way to this direction, that's 330. The difference between 360, which is the same as 0, and 330, that's the reference angle, which is 30 degrees. So it's between the x-axis and the hypotenuse of this triangle formed. So how do we apply this to a question? So let's say if you want to evaluate sine of 150. What can you do to help you to commit that to memory? So sine, based on SOHCAHTOA, is opposite over hypotenuse. Relative to the 30-degree angle, opposite is 1, the hypotenuse is 2, so sine 30 is 1 over 2. Sine 150, therefore, is also 1 over 2. However, 150 and 30 may vary depending on the sign. You need to figure out if sine 150, if it's positive a half or if it's negative a half. The magnitude is going to be the same. They're both going to be 1/2. But sometimes it could be positive, sometimes it's a negative. Now, sine is associated with the y value. In quadrant 2, is y positive or negative? Because you have to go up the y-axis, y is positive. Therefore, since sine is associated with y, sine 150 is positive. So this is the value of sine 150. It's plus 1/2. Have you ever heard of the expression, all students take calculus? In quadrant 1, it's A for all. Quadrant 2, students, so S. Quadrant 3, take. And quadrant 4, calculus. So what does this mean? Relative to sine, cosine, and tangent, the A part represents sine, cosine, and tangent. All of them are positive in quadrant 1. All students. So S means that sine is positive in quadrant 2. So the other two, cosine and tangent, are negative. T for tan. Tan, which means that cosine 240 will also be 1/2. But we got to figure out, is it positive or negative? So 240, we know it's in quadrant 3 because that's between 180 and 270. So cosine, which is associated with x, is it positive or negative in quadrant 3? Well, quadrant 3 is to the left. As you go to the left on the x-axis, it's negative. So therefore, cosine 240, take 5 pi over 3 and multiply by 180 over pi. You want the pi symbols to cancel. Now, we can do 5 times 180 divided by 3, or we can do 180 divided by 3 times 5. It's easier if you divide first,